Hello everyone. So today we are going to look into a very important category of problems in DSA known as DFS matrix. Basically grid problems, 2D grid problems, which we are going to solve using the DFS approach. So the problem like these, the number of islands or finding the maximum area of island or surrounded region or the Pacific Atlantic Ocean problem mentioned in Leetcode. So these all problems or any other similar problem which is based on 2D grid traversal, and we are been given some conditions in the question that we need to solve. We can solve this problem in the using this DFS matrix approach. So these I'm mentioning the problem numbers as well. So the problem number is for island is LC 200, this one is LC 695, a surrounded region is LC 130, and the Pacific Atlantic problem is LC 417. And these problems can be solved with the DFS matrix approach, which I'm going to discuss now. So the problem says that we have been given one 2D matrix initially, something like this, and we have to traverse this grid and return some appropriate answer. So the general approach for solving this kind of problems are, what you need to do is basically just traverse the grid. This is DFS matrix algorithm. Traverse the grid, then enter the grid at appropriate location. At appropriate location as per the problem, and then just call our DFS function. And inside the DFS function, what we'll do is we'll do three things only. We'll mark this current cell as visited where we are. Then once we have marked this, we'll apply the question condition, some things like that we are going out of bound, or we need to, in which direction we need to move, and where we need to stop. Basically those are the question conditions. And then we'll explore the neighbors in four directions, and the last step is return none or some value from the function that we want, depending upon the question. So this is the general idea for this algorithm, and now we can problem. So I'm taking this problem, surrounded region, to solve this, to apply this algorithm. And the problem says we have been given a n cross n matrix board containing letter X and O capture region that are surrounded. And there have been definition for region, surrounding region, and how the cell is connected. So definition for connecting is a cell is connected to adjacent cell horizontally or vertically to form a region. Connect every O cell and surround the surround region is X if you can connect the region with X cells and none of the region cells are on the edge of the board. A surrounded region is captured by replacing zeros with by replacing O's with X's in the input matrix board. So our board is looking like this. So I need this. So our board look something like this. It's a 2D grid. Okay. So that is good. So the 2D grid in form of a diagram or model look like this. So it's better if I use rectangle, that is easier to make. Okay, and we have been given the input method board something like this. So we have been given x, x, x and x, and we have to capture the surrounded region. And these are the O's that we have been given in matrix. Okay, and the problem says we have to capture regions that are surrounded. So first we need to find what are the regions that are surrounded. So here in the problem it says that the bottom region is not captured because it is on the edge of the board and cannot be surrounded. Okay, so first we need to understand like what is the region that we need to capture. So here we are, and here in the boundary we are sitting in the grid. So what we'll do is, as per the algorithm that I discussed, we'll traverse this grid line by line, row wise and column wise, and we'll enter this grid from the boundary, meaning we'll explore all the cell on the left edge, on the top row, on the right edge, and on the bottom row. Okay, so here we are exploring every edge, and then what we'll do is we'll look for O in the when we have found a O, we'll look for the surrounded cells that we have for the current cell. And if it is not a O, then what we'll do is we'll return back immediately. And if it is a O, then we'll explore its cells simultaneously from the uh, edge wherever. So let's say if we are exploring from first cell, we'll go into this direction and we'll see that this is a X. So we want to continue in this direction. So we'll continue exploring this, exploring this, exploring this. And once we found a O, then we'll look for its direction in all the four directions. So if we are exploring this in all four directions and we are seeing that there is not a 0, when there is not a O, then we need to end our search here. And if we have found a O, then we need to continue exploring that region. So we'll find one surround region, and as soon as we have found one surround region, we'll replace this O's with X in the end. And when we are traversing, we'll first mark our O's, that this is the cell which has a value of O and which is not surrounded. So we'll replace this with a value, let's say that is value is V. And so when we now change this matrix, we'll immediately what we'll do is we'll change V to O and O to X in the board. So we'll have our boundary, we'll have our grid in the way that we wanted. So our grid in the end will look like this. What we have to do is we have to simply change all these cells back to what we wanted. So this X we will change to this, we will get changed back to O. Here we have remaining X's the way we wanted. and the surroundings O will change them again back to X. So in this way, we'll have our answer looking in the way we want. So I hope you have understood the explanation, and now we are moving into the coding part. Now I'm going to write down the solution like we discussed. So we have m rows like described in the problem. There are m rows and n columns. So this is the rows and n is the number of columns. This is nothing but basically the length of matrix. So this whole length is number of rows, which is nothing but the length of the board list, and inside the board list we have lists which are of size n. We are calling those the columns. Okay, and now what we need to do is we just need to go into the cell one by traversing the board, and we need to explore the boundaries and from where we can enter the grid. So when I'm exploring the left and top boundary, we can see on the left we have the row value as 0, and on the column as and on the top we have the column value as 0, C value as 0. So I'm taking the product for top and left boundary, and for capturing the for moving for traversing the bottom I'm taking m minus 1, and for traversing in the right edge I'm just taking the column values n minus 1, and inside this I'm going to explore all these cells starting from these four edges. And now we need to define our DFS function. So like we discussed, when we first entered any cell we need to mark it as visited. So we'll say that this cell in which I'm currently on, that is being visited by me, so I'm going to mark it as V, and then I'm going to explore all the directions in the from the current cell. So which is this is the top, this is going to be bottom, so I minus 1 is the bottom, and then I need to explore the left. So left is j minus 1, and the right would be from the current location, right would be j plus 1. And now we need to apply the questions conditions such as out of bound, and when we need to return, like we discussed that if we have encountered not O, then we'll immediately return. So we'll say that if I'm going out of bound, so that is I is equals to 0, or I is greater than equals to m, or j is less than 0, or j is going to be greater than equals to n, then we will return. So this is the out of bound condition, and the condition for not finding appropriate 0 or O, then we'll immediately say that this region is not surrounded and we want to return. So now let's check our board. So our board would be looking like this. So here we will be getting a V, and others are 0, so we'll replace those again. So now let's see how our board is looking. So just I want to see my board. So now let's run and check our board. So our board is looking like this. So we have will mark the surrounded region which is not captured as V, and the captured region are marked as O. And now what we'll do is simply we'll traverse the board again and mark our visited not captured values of O's as X, and the surrounded region of O's as back as X. So in this way, we'll capture the thing that we want, the grid in the way we want. So for C in range n, we are looking for board values. So if my board of any cell value is equals to V, then we need to change that to O, so that board of I comma j is going to be updated to the O. Otherwise I want to update the remaining cell values as X. So in this way we'll have the board the way we need to answer back. So it says I, so this is R comma C, because we are traversing in R comma C when we are exploring the board. So this has been accepted. Now let's run our solution for all the examples test cases. So what about that my board cannot be empty? Okay. So it says the mn has a minimum of 1 and maximum of 200 rows and columns. So we will not be facing any null cells condition, and if there is any checks, like if there is no board, then we can also put a check. If not board value, then we can also just simply add one check for returning that I don't want to do anything, I just want to return out. So now let's submit our solution and see how it performs for all the test cases. So it has been fast accepted and it is running pretty fast. So this is the algorithm of traversing the 2D grid using the DFS approach. I hope you guys have liked my solution, and if you have liked and if you have found my solution, please do like and subscribe to the channel. It helps me reaching out to you with more such awesome content, and I hope I am helping you out in your interview journey. Please let me know if you have any particular problem in mind and I can have a look. Till then, be safe, and I will see you tomorrow with some new algorithmic problem which we can solve. Thank you. Have a nice day.